Welcome to the next video. In this video, we are going to talk about how to solve non-homogeneous linear recurrence relation through inverse operator method. This is a continuation to the previous video. There I discussed about the theoretical aspects of it. So in case if you have come across this video for the first time, please watch the previous video so that you get the context right. If you are new to the channel, please do subscribe it and share with your friends for good quality content. So let's start. So let us look at this particular problem. Yn plus 3 minus 12 yn plus 2 plus 48 yn plus 1 minus 64 yn is equal to 5 times 4 to the power n. So now if you look at this expression, this is already in a very suitable form. When I say it is already in a suitable form, first of all, they are asking us to solve it for yn. And if you look at this, it can be seen as, let me write, it can be seen as e cube of yn, because it is yn plus 3. It can be seen as 12e square yn plus 48 e yn minus 64 yn is equal to 5 into 4 to the power n. So this implies e cube minus 12e square plus 48e minus 64 yn is equal to 5 into 4 to the power n. Okay. So first of all, what is the characteristic equation? The characteristic equation is r cube because it is e cube here, minus 12r square plus 48r minus 64 is equal to 0. Here I have to write 48r. I mistakenly write 148, so it is 48r. Now if you solve this, this is clearly r minus 4 whole cube is equal to 0. I hope you understand. A cube minus 3 into a square b plus 3ab square minus b cube. So it is r cube minus 3 into r square into 4 plus 3 into r into 4 square and minus 4 cube. So basically it is r minus 4 cube is equal to 0. So we are getting r is equal to 4 comma 4 comma 4. So we have got three roots which are repeated. So what will be the general solution? The general solution will be, I hope you have seen that video earlier where I have discussed this, c1 plus c2n plus c3n square 4 to the power n. So that is the general solution. But the next part is that we have to find the particular solution. So how do you find the particular solution? You take f1 by fe, so that is e cube minus 12e square plus 48e minus 64, and that you need to operate on 5 into 4 to the power n. Okay. So for our convenience, if you allow me, I can even write this this expression e cube minus 12e square plus 48e minus 64 like e minus 4 cube. I hope you agree to this. 5 is a constant, so take it outside and operate it on 4 to the power n. Now I want you to note very important point here, that if you apply the formula where you directly substitute a in place of e, and again I would strongly recommend that please keep all the results in front of you so that you can understand that what I am talking. So one of the result was, which I have used earlier also, that in case of 1 by fe of a to the power n, you replace it by 1 by fa a to the power n. You replace e by a, right? But that is valid only in case f of a does not become 0. But here if you do the same thing, you realize that if you put 4 in place of e, so you get 4 minus 4 is equal to 0. So this result will fail. This result will not work. So in this kind of situation, what we do, we multiply it by 1, right? And we consider that 1 is a polynomial, and then we apply the formula of 1 by fe a to the power n and a polynomial, right? So proceeding, what we can do, if I consider this 1 as the polynomial, I take 5 into 4 to the power n, which I bring before this operator. That is what the formula suggests me. And in place of e, you replace it by ae, right? So this e becomes what? This e becomes 4e minus 4 cube, and that I have to operate on 1. Okay. Now proceeding forward, I have 5 into 4 to the power n and 1 by 4e is what? 4e is 4 plus 4 delta. E is equal to 1 plus delta minus 4 cube, and that I operate on 1. So this 4 and this 4 is cancelled. What I get is 5 into 4 to the power n 1 by, and 4 delta cube will be basically 64 delta cube of 1. So we are getting 5 and this 64, so 5 by 64, let me write separately, 4 to the power n, and we are taking 1 by delta cube of 1, and this I want to be very precise about, because this is something that possibly students most of the time make mistake. So if you look at 1 by delta cube, what basically this means, we have explained in the previous video that delta works like the differential operator, and 1 by this delta works like the integral operator, right? Just wait a minute. So this delta work as a differential operator, and 1 by delta works as an integral operator. So if I have to operate 1 by delta cube on 1, I am writing here, if I first operate 1 by delta on 1, what I will get? I will get n to the power 1 by 1. Means it is like if you integrate just 1, so you get x, so n to the power 1 by 1. If I operate 1 by delta square on 1, means I need to operate 1 by delta on n to the power 1. So that will give me n to the power 2 by 2 using the formula. And finally, if I operate 1 by delta cube on n to the power 2 by 2, what will I get? N to the power 2 will become n to the power 3 and by 3, and this 2 is already there, so I will get 6. So here we are getting what? Here we are getting 5 by 64 into 4 to the power n, and 1 by delta cube of n, which I have explained, is n cube by 6. Yes or no? So this is my answer, but usually we don't leave the answer in this form, so we can simplify it further. I can write 5 by, and you can multiply 6 into 64, whatever you get you can write, and 4 to the power n, and n cube is equal to what? N cube is equal to n into n minus 1 into n minus 2. So this is your PS, this is your GS. So you write your solution like yn is equal to, if I can write it over here, yn is equal to the general solution plus the particular solution. That part you can complete. Okay. So this is the first problem. Let us move to the next problem. So if you look at this problem, this is already in a very nice form. So let us start it directly. What will be the characteristic equation? The characteristic equation will be, and by now I hope you are clear, I can write it directly. It will be, or let me just write one more step so you don't get confused. Let me just remove it and rewrite the expression. So what I am saying, that if I look at this equation, this looks like e square an minus 5e an plus 6an is equal to 2n square minus 6n minus 1, which can be written as e square minus 5e plus 6an is equal to 2n square minus 6n minus 1. So what will be the characteristic equation here? The characteristic equation is r square minus 5r plus 6 is equal to 0. So this implies this will be like r minus 2 into r minus 3 is equal to 0. So we are getting the roots like r is equal to 2 and 3. So in this case, what will be the general solution? The general solution will be c1 2 to the power n plus C2 3 to the power n. But that is something we already know and we are quite comfortable with. What we have to find next is the particular solution. So the process is that we take 1 by Fe. So what is Fe here? It is E square minus 5e plus 6. So I write E square minus 5e plus 6, and that I need to operate on 2n square minus 6n minus 1. Now the first thing is that this is a polynomial in n. So whenever we operate this kind of operator on a polynomial, we need to change this into delta operator. So e should be changed into delta. So it will become 1 plus delta square minus 5 into 1 plus delta plus 6, and that I need to operate on 2n square minus 6n minus 1. Next is to simplify. So I am just simplifying it quickly. 1 plus delta square plus 2 delta minus 5 minus 5 delta plus 6. And we also need to change this polynomial into factorial polynomial. I hope this is clear to you, that whenever we are working with delta operator, we change it to the factorial polynomial. So this will be like n to the power 2 plus n to the power 1. How did I write it? In case if you didn't get, watch the previous video. N to the power 1 minus 1. So this expression becomes 1 by delta square 2 delta minus 5 delta, that is minus 3 delta, and plus 6 and plus 1. 7 minus 5 is 7 minus 5 is plus 2, and here we get what? We get 2 n to the power 2, and 2n to the power 1 minus 6n to the power 1, I think it is plus, and it will be minus 4n to the power 1 and minus 1. I hope you got it. So this is equal to what? This is equal to, now I hope you have come across this kind of situation in a differential equation course also. So you take 2 common and you write the expression in the form of 1 plus minus something delta. So you write it 1 minus 3 by 2 delta and plus delta square by 2, right? And here you write 2n to the power 2 minus 4n to the power 1 minus 1. So this gives you what? This gives you 1 by 2, and using the expansion now. So what is the expansion that we have to use? The binomial expansion, right? So it will be like 1 minus and if you allow me to write 3 by 2 delta minus delta square by 2 and whole to the power minus 1, that I need to operate on 2n square minus 4n to the power 1 minus 1. What is the next step? I write 1 by 2 and then I do the expansion. So it will be like 1 plus 3 by 2 delta minus delta square by 2. I hope you got it, because the formula that we are using is 1 minus x to the power minus 1 is 1 plus x square and so on. So I have written 1 plus x term. I also need to write x square term. So that will be like 3 by 2 delta minus delta square by 2 square, and then there will be some other terms also, but I am not writing it, and I will explain why I am not writing it, because the other terms will contain the higher powers of delta, which we don't need. I hope you are getting my point. The point that I am trying to make here, that if I write the next powers, the minimum power of delta means if I write the cube term, the minimum power of delta will be how much? It will be delta cube. So delta cube, but here we have a polynomial of degree 2 only. So if I operate delta cube on any polynomial of degree 2, what it will give me? It will give me 0. Okay. So let us move to the next page to solve the remaining part, right? Because we don't have a space over here. So let's move to the next page. Okay, so let's move to the next. So we have 1 by 2 here, and 1 plus 3 by 2 delta minus delta square by 2. Now this is very important step. that if I write the expansion of this term, I will get what? I will get the first term as 9 by 4 times delta square, and then delta to the power 4 b square term will be there, and then 2ab terms means delta into delta square will give me delta cube term. So basically other than the square of the first term, the other two terms in the expansion will have higher power of delta, means delta cube or delta to the power 4. And since we have a polynomial of degree 2, we are expected to write only those terms which have the powers of up to delta square. Let me rephrase my statement. Up to what powers of delta we need to write here? Up to that power of delta which is equal to the degree of the polynomial here. Suppose we have a polynomial of degree 3, then I will write up to delta to the power 3. If we have a polynomial of degree 7, then I will write up to delta to the power 7. And other terms, higher powers of delta, will basically, if operated on a polynomial of lesser degree, then it will give 0. So that is why it is not needed. So I am closing the bracket here, and then I am writing 2n to the power 2 minus 4n to the power 1 and minus 1. Now let us do one simplification, that write 1 plus 3 by 2 delta, and you have 9 by 4 and minus 2 by 4. So basically it will be 7 by 4. I hope you got it. 7 by 4 delta square, because 9 by 4 minus 1 by 2 is how much? 9 by 4 minus 1 by 2. So that is basically 2 by 4. So 9 by 4 minus 2 by 4. So that is 7 by 4. And here we get 2n to the power 2 minus 4n to the power 1 and minus 1. Now let us do the operation. So 1 by 2 and 1 into this. So I will get just 2n to the power 2 minus 4n to the power 1 and minus 1 plus 3 by 2. And if I operate delta on this, I will get 2 into 2n to the power 1, right? And if I operate delta on this, I will get minus 4. And then I will write plus 7 by 4. And if I operate delta square on this, so applying delta square on this basically means what? We already have applied delta here and we have got this. So if I apply delta square, means I need to apply delta on this, right? Means if I apply delta on this, I will get 4, and n to the power 1 will give me 1, and minus 4 will give me constant. So I just get a 4 over here, and I close the bracket. I hope you got this point. In case if you have not, please do it yourself and then confirm that what I am suggesting is okay. So we get 2n to the power 2 minus 4n to the power 1 and minus 1. And now let us multiply the term. So 3, this 2 and this 2 will cancel. So 3 into 2 will give me plus 6n to the power 1. And here you have 2 and 4 cancel. So 2 into 3 is like minus 6. And then here we have plus 7. This 4 and this 4 term cancel. Now this minus 1 and minus 6 and plus 7 will also cancel. So I am getting 1 by 2 and 2n to the power 2 and minus 4 and plus 6. So plus 2n to the power 1. So basically this 2 can be cancelled. We write n to the power 2 plus n to the power 1, and that is nothing but n into n minus 1 plus 1. If I change the factorial polynomial into the regular polynomial, so I will get what? I will get n square minus n plus n. So this cancel and we get n square. So this is what we have got. We have seen that in the previous slide that my general solution was C1 2 to the power n plus C2 3 to the power n, right? So what will be the final answer? The final answer an will be C1 2 to the power n plus C2 3 to the power n and plus n square. So this completes the solution of this problem. Please try to solve the whole problem, like starting from here, and without, once you have seen the proof, once you have seen the answer, now try to reproduce your own answer, and then identify that where you are finding challenge, and put those challenges in the comment box so that I can understand that these are the points where I need to highlight, or I need to put more weight behind it, right? So let us do one more problem here, right? And in this problem also, if you look at it, what will be the first of all characteristic equation. So before I write characteristic equation, let us arrange the terms in such a way that it is easier to write. So we are getting something like n minus 2. So I want to make it an, means we can apply shift operator on this. How much? Like e square of an is equal to 4 e square of an minus 1 minus 4 e square of an minus 2. Some of the people may not find the need to apply it. They can directly write, okay, and then n I am shifting to what, n plus 2, because I am operating e square. So this will become n plus 2 plus 1 and then 2 to the power n plus 2. So we got what? We got e square an is equal to 4 an plus 1 minus 4 an, and this is plus, and n plus 2 plus 1 is equal to n plus 3, and into 4 2 to the power n, 2 square. So this is like 4 2 to the power n. So we get what? We get e square, and e square basically you could have written an plus 2 also. Let me first correct it. It is better to write everything in the same form. So I can write it like an plus 2 minus 4 an plus 1 plus 4 an is equal to 4 n plus 3 into 2 to the power n. Okay. So this is like, now let me collect the term e square minus 4e plus 4, and here we have 4 into n plus 3 into 2 to the power n, and I missed to write an here. So what is the characteristic equation? The characteristic equation is r square minus 4r plus 4 is equal to 0. So that will give me r minus 2 whole square is equal to 0. So that will give me r is equal to 2 and 2. So what will be the general solution? General solution will be c1 plus c2n and 2 to the power n. Now let us find the particular solution. So to find the particular solution, I have to operate e square minus 4e plus 4 on 4 times n plus 3 2 to the power n. Now this is a polynomial multiplied by a to the power n. So let us check the list of formula that I have discussed earlier and see which can be applied. I am applying, and in case if you do not agree, check the formula again so that you don't miss it. So 4 is a constant out of this. Now 2 to the power n I will take also out of the operator, because this is the formula suggests, and then you replace e by ae. So it will become 2e square minus 4 into 2e plus 4, and then I write n plus 3, right? So this is equal to what? This is 4 into 2 to the power n 1 by 4e square minus 8e plus 4, and then we need to apply it on n plus 3. Now at this place, this is a polynomial in e, so I need to change it in terms of delta. So I will write 4 into 2 to the power n, and what it will be? It will be 4 and 1 plus delta whole square minus 8 1 plus delta and plus 4, that is I need to apply on n plus 3. Now I get what? I get 4 2 to the power n, and we get what? We get 4 plus 4 delta square a square plus b square plus 2ab. So 2 delta plus 4, so how much? 8 delta, and minus 8 delta plus 4, and that we need to operate on n plus 3. So this 8 delta and minus 8 delta is cancelled. This 4 here and this 4 8, and this minus 8 is cancelled. So we got a very good looking situation. 4 2 to the power n 1 by 4 delta square, and then we need to operate it on n plus 3. Okay. So let us proceed to the next. So what we get is 4 2 to the power n 1 by 4 delta square. So this 4 and this 4 is cancelled. We get 2 to the power n 1 by delta square, And I have told you in the previous problem also that whenever we apply or work with delta square, we need to change the regular polynomial in terms of factorial polynomial. So now it is 2 to the power n, and we have to operate delta square on n to the power n. So if I operate 1 by delta on n to the power n, it will give me n to the power 2 by 2. The first. If I operate 1 by delta square on n to the power n, it will give me 1 by delta of, and this I take n to the power 2 by 2. So 1 by 2 is a constant, and 1 by delta of n square will give me n to the power 3 by 3. So I get 1 by 6 n to the power 3. I hope you got it. It is just like integration, that if you have x, you get x square by 2, and then 1 by 2 x cube by 2, so that is x cube by 6, right? First 1 by delta will give me n to the power 2 by 2, then 1 by delta square means I need to operate 1 by delta on this, so this 1 by 2 is constant, and this will give me 1 by 6. So we are getting 1 by 6 n to the power 3 and plus 3. Now if I operate 1 by delta on a constant, 1 by delta on a constant, so what it will give me? It will give me n to the power 1. And if I operate 1 by delta square on 1, so it will be basically 1 by delta of n to the power 1. So that is n to the power 2 by 2. So here I get 3 n to the power, sorry, let me correct it here. So 3, and what we get? We get n to the power 2 by 2. So the final answer will be 2 to the power n, 1 by 6, n to the power 3 factorial polynomial, and 3 by 2 n to the power 2 factorial polynomial. As I have told you that there is a practice to write the answer in terms of the regular polynomial. So I can change it. I can write 1 by n, 6n into n minus 1, n minus 2. And this I can write 3 by 2 n into n minus 1. So this is my what you call general solution. We already have seen what is the particular solution. So we can write the combination of both of it. What was the PS? General solution was C1 plus C2n 2 to the power n. So an will be equal to C1 plus C2n and 2 to the power n. So it will be 2 to the power n, 2 to the power n, and plus this part. I hope you can copy this part over here. So that will be the answer, right? So I hope you are getting the things. This is what I wanted to discuss. I would suggest you to do some more problem solving, and I leave a problem for you to solve. This is a problem that I leave for you. Please try solve it and let me know that whether you are able to solve it or not. Once you solve it, put it in comment box that yes, this is what my solution is. I will see that how many of you are able to solve these problems. So that is all for this video. I again repeat that to get a better idea about the content that we are discussing on this channel, you need to watch the videos in the sequential order. I have created a separate playlist for discrete mathematics where we are putting the videos which are numbered order wise. So if something L1 is there, like in one of the video, if L1 is appearing, means this is the first video. If L2 is appearing as the part of the title of the video, it is the second video, and so on. So I think we have started the recurrence relation topic lately, and we are uploading videos on recurrence relation. Once it will be completed, we will be talking about relations, and Hess diagram, partially ordered set, and everything that will follow. So thank you and have a very great day.